fishing boats did part of harbor at the same time. One traveling east, the other south. Okay. Before we do anything, what type of angle do we develop when we travel one direction south and the other direction east?
Right angle.
Right angle. Okay. So that is a huge part of this question. Okay. Says the eastbound boat travels at a speed of 2 miles an hour faster than the southbound boat. Do we know how fast the southbound boat travels? No, they don't tell us that. So if they don't tell us that, what should we let it be?
X.
Let it be X. Okay. So then the eastbound is going to be 2 more than that. So X plus 2, right? Pretty easy. Okay. Now understand, are those distances or are those rates? That's a rate. Okay. Rate. Rate. Now I'm going to draw in that because they say after these 2 hours, these 2 boats stayed on these courses and they're going to be 60 miles apart. Well, when we say things are 60 miles apart, we go like the shortest distance possible, right? So from point A to point B. And that's going to be along that blue line, which that blue line is a what? The hypotenuse. And hypotenuse in this case, this value of 60, is that a distance or is that a rate? That's a distance. So, if you were a person that said, I know I put the information in and I used the Pythagorean theorem, but if you left the Pythagorean theorem in that form, if you went x squared plus the quantity x plus 2 squared equals 60 squared, you're wrong because you're relating rates with distances. The Pythagorean theorem is talking about distance squared plus distance squared equals distance squared, right? So I need to turn these things into distances somehow. And this is what people, and I did it on purpose when we read this, they glaze over that 6 hours. They think that's unimportant. Okay? But that 6 hours tells me if I traveled at a rate of x for 6 hours, okay, let's say x is 4 miles an hour, and I did that for 6 hours, do I know a distance from that? 6 times 4, right? So now if it's just x, 6 times x gives me that distance. Okay? And then this one obviously then is x plus 2 times that 6. Okay? I'm going to rewrite that as 6x plus 12. Is that okay? So people did that. And then I see people coming up to me saying, I've got all this work, and I've got the idea that I've got 6x. And I'm going to square that. Plus then 6x plus 12. And I'm going to square that. Should equal 60 squared, right? Because all that is a squared plus b squared equals c squared. It's the Pythagorean theorem there with your distances, correct? But now is where they make another mistake and they say, well, that's going to give me 6x squared when I square it. Does that give me 6x squared here? What's that really give me? 36x squared. Okay? Now, they're saying, okay, I got that, but now I make this, I change that to 36x squared plus 144. Is that right? Can I write that as 36x squared plus 144? Is that the only thing I need there? No, I got a FOIL, right? So I'm missing my O and I. So what I'm going to do is I'm just going to multiply those 2 things together. What's 6 times 12? 72. And if I double that, I get 144. So I got 144x right there. Remember, you got to FOIL that out. And then the last part, 60 squared, 3600. Okay. So this is going to give me, what, 72x squared plus 144x. Subtract that 144 over. Oh, sorry. Subtract 3600 over. Gives me 3456. Alright. Now I'm looking, that's an ugly quadratic, right? Okay, big numbers. So if you're a person that says, hey, I see big numbers, I automatically go to quadratic formula, that's fine. But what I'm seeing in this row here is that 3600 is a factor of 36, right? Or 36 is a factor of 3600. 36 is also a factor of 144. So I'm thinking here I could probably divide, and 72 is twice 36, right? So there's a lot of common values in here. I'm thinking that that's all probably going to divide by 72. I know 144 does divide by 72. So I want to see if this 3456 does. And what do you know it does? So if I divide everything by 72, I get x squared plus 2x minus 48 is equal to 0. And now that's something we should be able to factor pretty easily. Because x minus 6 and x plus 8. X is 6. X is negative 8. Okay. And if you were to use the quadratic formula right here, it's perfectly fine, nothing wrong with that. You're going to get really big numbers, but hopefully we're going to use our calculator to kind of muddle through that for us. But you'll get down to integer solutions. Okay. Whenever you use the quadratic formula and you get down to really nice solutions that don't have a radical part to them anymore, that tells you that, factor by grouping, or in this case we use the product sum technique. It tells me one of those shortcuts would have worked instead of the quadratic formula. Does that make sense? So now x is, what was x representing up in our problem? The rate. Okay. So a rate, just a speed, correct? Okay. So can it be negative? Zach, I know you're slow, but negative 8, pretty slow, right? Okay. So we can't have that. All right. So 6 has got to be our rate. And there's a built-in check for this if you want to make sure you've done this right. If 6 is x, and this would be 36, correct? Okay, that distance. And this distance here should be 36 plus 12, 48. So should I be able to take 36 squared plus 48 squared and see if that gives me 3,600? And if it does, I know that's a right triangle, and I've satisfied the fact that we went southbound and eastbound from one another. And I told the last class this, what I like about this question is you got to pull from some previous math courses, right? You got to pull from geometry, 7th grade and 8th grade math, distance equals rate times time. And you got to piece things together to get, and even algebra 1 and algebra 2, by developing these and foiling those correctly, to end up with something that we're currently working on. All right. So it's very important that we are able to pull from previous courses. Okay? That's why they give you prerequisite requirements to get into this course. A lot of things in this class are going to be that way, where maybe we're working on the quadratic formula, but we got to use maybe 2 or 3 or 4 ideas from previous courses before we can get to that quadratic equation that we're working on. So keep that in mind as we move through. Somebody said question 7. They wanted to go over that. Does this make sense now? We feel comfortable with that one?
Mr. Fay, I don't want to be this guy, but...
Well, be that guy.
When I did this question at home, I did, computationally speaking, I did the same thing you did.
Okay.
But I got a really ugly quadratic, and it wouldn't go down to anything else.
Can somebody hit the red button on top of the camera? It's like towards me.
I can't see it.